A scientific calculator is recommended. I'm not reading the rest of the flavor text. Hey guys, I'm Possessed. Welcome to 27 million. That's what I'm going to be calling this module. You can also call it 13 partitions. But I think this is made by Frog, yeah? Yeah. Frog's mathematical module where you divide 13 LEDs, whatever, 13 partitions, 27 million, something like that. This is the module. Here's what it looks like. Yeah, 13 LEDs, a 6-character string in the middle, and a number in the bottom which you can change from 0 to 12. So, what is this module? This module consists of 13 LEDs, yep. You're gonna have to group up these 13 LEDs into some number of groups, each containing some number of LEDs containing certain LEDs. So basically, you might have a group of 13, which is every LED, or a group of 12, and then a group of 1, with that 1 remaining being any of the LEDs, or 13 different ways to group. It's complex. You can group up the LEDs, and there's different ways you can group up the LEDs, even with the same group numbers. So, what the hell is that going to look like? Let's say we're gonna have let's grab this one. Say we calculate that we're gonna have a group, 4 groups. One of them's gonna contain 5 LEDs, the other's gonna contain 4, another one's gonna contain 3, and the last one's gonna contain just 1. So we're gonna have a group of 5 LEDs, a group of 4 LEDs, a group of 3 LEDs, and lastly a group of 1 LED. So we don't know if it will look like this, or maybe you two are swapped, or maybe you two are swapped. We don't know which one of those it's going to be, and we'll have to find out which one it will be to solve the module. So as you might have noticed, module does not strike. You won't have to worry about that. It's just pretty lengthy and mathematical. So let's get to the solving process. To start off, we're going to need the 6-character string in the middle and convert it from base 36 to base 10. Victor, Bravo, Whiskey, 0, Kilo. Yes, very important. You're gonna module this by the main man himself, 27 million. And we have this number. This is gonna be called our base index. Keep it around. So now that we have our base index, calculated from our string, which is what step 1 is, you're gonna go to Appendix B and find the cell whose bottom value, so that's this one or this one or this one, is greater than our base index, but the previous cell is less than our base index. So you're basically going to find out where your base index fits into these cells. So our base index is greater than this one, but it's going to be less than this one. So we're going to take the right of the 2 cells. This table wraps around the rooting order, so yeah. From that cell, we have this information. The first row is going to be our R values. The second row, inside the square brackets, is going to be our IPC. And the third row is going to be our PTF. We're going to use these. Yeah. So the R values, I'll explain what those are. Basically, we're going to have a group of 4 LEDs, a group of 3 LEDs, a group of 2 LEDs, another group of 2 LEDs, and then 2 singles. But that's not solving the module, so we know that that it's not going to be grouped up exactly like this. Like, it's going to look a little different. But those are the sizes of the groups. So now we need to calculate which LEDs are in which groups. So continuing on, we're going to have to calculate in index A. I'm just going to call this IA. And it's going to be derived from this equation. So I'm just going to calculate that. We have index A. Now that we have index A, we're going to use it later. Right now, we're gonna have to calculate the IPC and the SNC. You might think we already have the IPC, and you'd be right. This equation, once we plug in all our numbers, is gonna get our IPC. But we're gonna have to run through steps 3 to I think 6 multiple times, and we're gonna have to calculate the IPC every time. So let me explain the IPC equation. We're gonna have n factorial divided by whatever this is. So what is n? N is the number of LEDs you have not set yet. So we know that in our final answer, we're gonna have a group of 4 LEDs, a group of 3, a group of 2. One sec. Another group of 2, and then a group of 1, and then another group of 1. We have 12 LED or 13 LEDs, 0 index, and we're gonna just assign these in these groups by a bunch of equations. So we have 13 LEDs that we don't know the current positions of. The n is the number of LEDs you don't know the current position of. So n is currently 13. You can open the brackets. R is just going to be these values here. So 4 factorial, 3 factorial, 2 factorial, 2 factorial, 1 factorial, and 1 factorial. And then J is going to be the frequency of each number in R. So taking the first number in R, it's 4. How many times does 4 appear in R? It happens once. 3 appears once. 2 appears twice. So we're gonna 2 factorial. We already did 2. 1 is gonna appear twice. And that is gonna be our IPC. That's how you know you're doing it right, if it matches up. So we already know our IPC, so this is useless. Our SNC is going to equal to 13 factorial. Remember, n is the number of unset elements, unset LEDs. R and n minus R. So there's 2 R's. There's the R indexed, which is your index in the table. And there's the R that's just what your current subset you're working on. So you're going to work on a subset, so which LED appears in this group, which LED appears in this group, which LEDs appear in this group, and so on. You're also going to be grouping up the ones into their own groups. So each group of one LED is going to be grouped up into its own kind of group of groups. So we're going to work right to left. Starting with the rightmost group, we have the one group, which is going to consist of 2 elements. So R is going to be currently equal to 2. We're going to multiply this by 13 minus 2, and then raise that to a factorial. Our SNC is 78. Now we're going to calculate our CPSN out of the things we just grabbed. And now we're going to calculate our S and V, which is based off of our CPSN. We're going to have IA, and now we have our S and V. S and V is not always going to be an integer value, so don't worry about it. We're going to keep S and V as it is, but we're going to be using our SNV, the floor of our SNV, to calculate which LEDs are inside of our first group, inside this one. So the floor of SMV is 56, and we're gonna have to figure out which LEDs are in our one group based off this number. So how do you do that? You're gonna scroll down to here, Appendix A. So basically, how this works, how SMV works, is it's gonna count up each set of LEDs that you can have. So 0, 0, and 0, 1, 0, 0, and 0, 2, 0, 0, and 0, 3, and so on. And then when you get to 0, 0, 12, you can wrap around to 0, 1, and 0, 2. Note that there is no 0, 1, 0, 0 because that is the same as 0, 0, and 0, 1. So that's what SNV is. We're going to count up to the 56th set of 2 LEDs out of the 13 we don't have used right now. You can do this manually, or you can use Appendix A to speed it up. And I'm going to be using Appendix A. So let's get everything out of the way. We just need SNV at this point, and floor as well. So we're going to have 4 variables, an R, a V, an S, and an E. Our R is going to be set to the number of elements in the current set we're working in the current group we're working in. So there's 2 elements in the one group. Our V is going to be set to 0, or is going to be set to the number of set elements. We have not set anything yet, so V is 0. S and E are both going to start out at 0. We're going to index into the table, where R is the column and V is the row. And we're going to pick a variable S equals 0, add the selected cell's value to S, so 12, and then every cell below it, stopping at a cell once the addition of its value to S makes it greater than S and V. I'll give an example, and we're not going to add the value that makes it go over S and V. So we landed on this one. So if we can add 12, we're going to add 12. Yes, we can, because it's less than S and V. We're also going to add 11. If it's less than S and V. At 10, at 9, at 8. We can't add 7. 7 is evil. So we stopped at this cell. The one we can't add. And we need to set E to the number of times we move down in the table. So we move down once, twice, 3, 4, 5. Move down 5 times. Awesome. Now that we have E is 5, we're going to take the 5th element, 0 indexed, out of our current unset elements and place it into our group, into our one group. So 0, 1, 2, 3, 4, 5. We're going to take it out and put it in here. So now we need to iterate once more. But before we do that, we have to subtract S from S and V. We have to add E plus 1 to V. And we have to subtract 1 from R. Now I can reset S and E and do the same thing again. So R is 1, V is 6. You can add 1, add another 1, 4, 5, 6. S is equal to S and V, which is allowed. So you added 6, so 1, 2, 3, 4, 5, 6. And the 7th one is going to be too much, so we're not going to do that. It took us 1, 2, 3, 4, 5, 6 move downs to get to the evil cell. 1, 2, 3, 4, 5, 6. Yep. So E is equal to 6. We're going to take the 6th element. We're going to take the 6th element that is smaller than the ones we've used in this step. So we've used 5. So we can't use any of these. We have to use these. And we're going to take the 6th element 0 index from these. 0, 1, 2, 3, 4, 5, 6. That's 12. And we're going to remove 12 from our list. So now we have set the LEDs are in our one group. We don't need to worry about this anymore. And we can go back up here. Okay, now that we've removed 12 and 5 from our groups and put them into, from the unset elements and put them into the set elements, we're going to recalculate the IPC. So IPC formula is here. IPC is equal to N. N is currently 11 because we have 11 elements in our unset group. Yeah, 13 minus 2 is 11. Factorial. We divide that by 4 factorial, 3 factorial, 2 factorial, 2 factorial. We're going to exclude the ones because we've already set that. We're going to multiply this by 4 appears once, 3 appears once, 2 appears twice. This is our new IPC. Okay, so this formula is actually a really weird way of just saying we're going to take S and V, or remove the the actual whole portion, or we can multiply by 1. And then we're going to multiply this by our new IPC. And this should give you very close to a whole number. We're going to round it up to a whole number. This is going to be our new index A. So we have our new index A, we have our new IPC, and we're going to go back to here. We've calculated our IPC. Our SNC is going to equal to 11 factorial divided by the current subgroup we're going to solve. So 2 factorial times 11 minus 2 factorial. SNC is 55. We're going to calculate CPSN. And we're going to find SNV. Because our SNV is currently 30. We need to find out which elements are going to fit into this group based on SNV. Let's go back down to Appendix A. Appendix A. Our R is going to be 2 because there's 2 elements in this group. Our V is going to be set to the number of set elements, which is 2. And S and E are both going to equal 0 right now. We also have our 4 of our S and V, which is 30. And we're going to do the same process as before. Start with row and column of R and V. S is 10. Yep, that's legal. 9 is allowed. 8. 7 is not allowed. We stop at 7. That is 1, 2, 3 steps to get to 7. So we're going to take the third element, 0 index, from our set of unset elements. We can use the ones below 12 and 5 now because it's a different group. So 0, 1, 2, 3, and 3. Right? 1, 2, 3. Yeah. 0, 1, 2, 3. So 3 is going to be in this group. Remove 3 from our list and subtract S from S and D. Subtract 1 from R and add 3 plus 1. E was 3. 3 plus 1 to V. And we're going to go again. 1 and 6. S returns back to 0. E returns back to 0. We can add 1. Add another one. We can add another one, but not an extra. So we added this one, this one, this one, but not this one. We stopped at this one. E is equal to 1, 2, 3 again. We're going to take the third element after the one we just added. 0, 1, 2, 3. Put in our group. And that is our entire second group done. And we don't need this stuff anymore. Now you repeat the module until you find all of the LEDs in each group. You can calculate your IPC again. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 elements, which is 13 minus 4. Yep. 9 factorial divided by. We saw this one, so we're going to do this one. 4 factorial times 3 factorial times 2 factorial times 1 factorial, 1 factorial, 1 factorial. That's the frequency of those numbers. We have our IA, which is S and V, module 1 times your IPC. We're going to round it to 3 decimal places just because floating point precision. Now you're going to recalculate your SMC. SMC is equal to 11 factorial divided by the current group we're solving factorial times 11 minus current group factorial. Calculate the CPSN. Yep, our CPSN is an integer value. Our S and V is not going to be an integer value. Index alpha divided by CPSN. And we have another S and V. Alright, back to Appendix A. So R is 2. Our V value is going to be 1, 2, 3, 4 elements are set. Our S and E are going to be 0. And we have our floor of S and V. I'm going to start column R, row V. And we start an 8. Can we add 8? Yes. Can we add 7? No. We stop at 7. E is 1, so we're going to grab the 1, the first element, 0 index. Remove it. And we're going to subtract S from S and V. Subtract 1 from R. Then add E plus 1 to V. And we're set both of these back to 0. Alright, going again. Column 1, row 6. Can we add 1? Yes. We can add another one, but not a third. So we can add these two, but not this one. That is 1, 2 movements. So we're going to grab the second element, 0 index, after the one we just placed. So 1, so 0, 1, 2. There it is. We set element 6, and we don't need to bother about the rest. There it is. That's back out of Appendix A, and now we're going to repeat the process again. So current unset elements is 7. We have a group of 4 and a group of 3. Each of those numbers appearing once. You say the same. 7 elements. The current group is 3 elements in size. So that's our SNC. CPSN, SNV are going to stay the same. Go back down to Appendix A. We have R is equal to 3. B is equal to 1, 2, 3, 4, 5, 6. Yep, 6. S and E are both 0. And our S and B conveniently is integer, so let's get started. Column 3, row 6 is 15. We can do that. We can't add 10. It's gonna be too much. That is 1 movement to E. Because we're gonna take the first element, 0 index, add it to our current group. I'm gonna subtract 15 from S and V. I'm gonna subtract 1 from R. You can add E plus 1 to V. Reset both of these. And do it again. Column 2. Row 8. We can start at 4. That's allowed. 3 is allowed. 2 is allowed. 1 is not. That is 1, 2, 3 movements. E is 3. So we're going to take the third element, 0 index, after the one we just took. So 0, 1, 2, 3. This one. I'm going to subtract U, lower U by 1, add 3 plus 1. And reset both of you. Column 1, row 12. This is too much already. So we didn't even move. E is going to be 0. We're going to take the 0th element after the one we just took. And we found our 3 group. And by process of elimination, our 4 group is going to be whatever's remaining. Alright, now you have all of our groups. So now let's actually submit these into the module. The LEDs are ordered 0 to 12 north clockwise. And to set LEDs in the same group, just press them while your middle number is the same. It's pretty obvious. Doesn't matter if this is group 0 or group 1, as long as these 4 are in the same group. It should be fine. So we're going to take the 0 LED. 1, 2, 3, 4, 6, 7, 8, and 9. That's the one group. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's another group. 1, 2, 3, 4, 5, 6 is another group. 3, 4, 5, 6, 7, 8 is another group. 12, and 5. That is 27 million. And that's how you solve the module. It takes a long time. I can probably speedrun it in about 20 minutes if I'm going fast. Appendix A is a little confusing. Just consult the video. A lot of the wording of the manual is a bit confusing. Just consult the tutorial. These equations are going to be a godsend. And if you need to practice, take a look at the log. So that's going to be it for me. I might show a speedrun attempt of this module to show you how it looked like going fast. But I'm going to take a short break because my voice is getting dry. All right, time for the speedrun attempt. Wish I zoomed in closer. Okay, 36 to about 5, and it's not 5.10. Module this by 6.4.37. Put this in the bottom. This one. Yeah. FPC, SNC, CPSN is equal to FPC divided by SNC. SNV equals IA divided by CPSN. Then IA is equal to round. Into SNV times IPC. 3 decimal places. SNC is currently 13 divided by 1 and 12 factorial. 0, 0, 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, and 12. Twice we have third elements. Let's see, it's not 12 factorial divided by 3 factorial, 3 factorial, 2 factorial, 2, 2. It's 2 and 3. 12 and then 2 is 10. 8. You're done. You're done. 38. Eight. 6. You're gone. You're gone. 19. 6, 6, 3 and 3 now. You're gone. If 0, 0, 0. R equals 2, V equals 1, S equals 0, U equals 0, minus 61, it's S. 2, 1, 11, 10, 9, 8, 7, 6, 5, 4. 1, 2, 3, 4, 5, 6, 7, 8. 8. Get this 1, I'm just gonna go back. New one. We have 2, 3 preset. 0, 0, and 38. 9, 8, 7, 6, 5. It's 5. Then that's 3. Eight. Other 2, these for like 5. You're done. You're done. 19. Count 5 is 7, 6, 5. And we're going to get zeros. 0, 1, 2, 3, 4, 6, 7, 5, 8, 10, 6, 12. Bam! 630. That's awesome. Very good. That's how you speedrun 27 million. Just do exactly what I did.